Hey guys, in this video we're going to explore a pretty interesting inbuilt Python module called inspect, which provides several useful functions which help you get information about your classes, functions, modules, etc. So in a way, the inspect module helps you inspect various aspects of your Python code or program. In this video, I'll be showing you several useful functions provided by this module and various scenarios where you may actually use those functions. So without any delay, let's get started. Okay, so here is the first application of the inspect module, which is you can use the inspect module to examine the contents of an object. So let us see how to do that. So let's take an example of the request module in which you are just using the get function to get a response. So here is the response object and you can use r.content to get the content of your response, right? So we made a request to some URL and we got the response, right? So now let's say you want to get a list of all the properties and methods provided by this particular object. So what can you do? So Jupyter Notebook, as you know, has a feature in which you just do r dot and then press tab and then you will get a list of all the available property and method names, right? So that is an option. So for example, you can do r.json and then you get the value, right? So this is an option, but what if you want to retrieve the list of all the property and method names and their values programmatically? In that case, you use the inspect module. So you just import inspect and then inspect dot get members, in which you just pass any Python object. In this case, it's a response object, and then you get all the available property and method names, as you can see here. So here you get a list of tuples where each tuple has two values. First is a property or method name and second is its value. For example, this is a property whose name is double underscore a double trs double underscore and then the value is a list. But here double underscore bool double underscore, it is actually a property method name where you are getting a method like this, right? So in this way, you are getting a complete list, you're getting the complete picture of your Python object. So this is where you can use the get members function of the inspect module. Okay, so let us check out the second application of the inspect module, which is retrieving the source code. So when you import any class, module or function, you do not know what the actual source code is until unless you have opened the file which contains that particular piece of code, right? So you have to open that file to see the piece of code, but there is some other way as well which you can use, which is inspect modules get source function. So let's say you have requests.request, right? So this is the class in the requests library and you want to see the code for it. So what you can do is you can just do inspect.get source. So what this will do is that it will give you the source code, and if you want to see it properly, just print it. And here you go. So this is the code for the request class in the request library, right? So yeah, so you can always get the source code programmatically in your own Python code in this way. And also you can get it line by line by doing get source lines. So let me do it in another tab. Okay, so get source lines will provide it to you line by line. So you may have some scenarios where you want to get a particular line of a particular function or a class. For example, you must have seen the tracebacks where it specifies you the particular line where the error happened, right? So how does it know that in which line the error happened? So for those kind of cases, you need to get the breakdown of the source code line by line. So there it may come handy. So inspect.get source lines and you get it a list in the form of a list of strings. So yeah, so this was get source lines. And one more interesting thing is that you can use the inspect module in the CLI form as well, which is command line form as well. So what you have to do is python 3 -m inspect So -m is actually used to run the inbuilt modules, and inspect is the name of the module, and then inspect module provides you a CLI command in which you have to just specify the name of a module. So let us provide the name of a module as requests, and you can use a colon to specify that you want the source code of a particular class or function only. So let us say if we want to get the code for request class only, and you run it and you get it. So yeah, so this is how you can get the code for any class, function, method in the command line as well directly. So it is a pretty fast method as compared to finding that file and then opening it and all, right? But nowadays all you know is that you have some IDEs like PyCharm, VS Code, where you can directly open the source code of any imported module. Okay, so this was it, and now we can move on to the next part, which is okay, so we have a get doc as well. So get doc is not that special because it can be done in some other ways as well. So request.request, and if you use the doc thing here like this, you get the documentation, the doc string like this, right? But there is another way as well, which is inspect.getDoc, in which you can pass any class, function or module, and you will get the complete documentation for it, right? So you pass any object and you will get the documentation string for that object. And finally there is something called file, get file. So let's say you want to get the location of the file from which a particular, where the definition of a particular object is residing. So what you can do is inspect.getFile, and then you just pass any object. So let me just pass requests. So let's see what happens. Look at that. Now you know that at this place you have your file which contains this particular piece of Python object. Okay, so the definition of this object is in this particular file. So that is what you get to know by this. So yeah, so these were the different ways of retrieving the source code. Okay, so now let's check out the third application, which is creating a tree of the given classes. So when you get a group of classes, then there might be some sort of inheritance between them, and that inheritance can be used to create a class tree. So in the class tree, you will have the nodes as the classes, and inheritance will be a kind of an edge between two classes, right? So how do you get this kind of information programmatically? So for that, again, you can use the inspect module. The inspect module has get class tree function. So what it will do is that it will give you some information which can help you to understand the tree formation in which these classes are being placed. So inspect.getClassTree will accept a list of classes. So let me pass A, B, and C here, and we are getting some kind of data structure. So let us keep it like tree equal to this. So tree is this, right? So let us try to comprehend it. Tree 0 will give you the root. It is always the root. And after that, tree 1. So in the tree 1, we are getting this complete data. And now in the tree 1, what is the rule is that you just go through each object one by one. If an object is not in a list, then it means that it belongs to that level. So after root, the next level is A, so we put it like this, A. Now when I go to 1, which is the second element of this list, you get another list. So another list means next level. So we move to the next level, and in the next level, the first element is this, which is B, which is a child of A. So we put it like this, B. Okay, let's move to the second thing. And now we get another list, which means that we move to the next level, and on the next level, let us see the first element, which is C. So, and it is the child of B. So A, B, C are like this, one level after another, and there is only one element here, right? So yeah, so in this way we have parsed the complete tree, and we understood how are all these classes related. So just as an exercise, what you can do is you can try to replace B by A here, and then you can try to see the tree and try to see if you can make it like root A and then BC like this or not. Okay, so that is left as an exercise. Okay, so let's move on to the fourth application now, which is not something very super useful, like which you will require to use, but still it is better to know. So whenever you use a function, you want to know its signature, right? You want to know what are the different arguments, what kind of arguments are they, right? So in order to get that information, we usually use the IDs. So we get something like this, right? We get this kind of information directly, so we do not have to read the complete source code, we do not have to open the file which contains the source code, we directly get this information. And in order to get the information in a programmatical way, what you can do is you can use two functions are there, signature and get full argspec. So let's see them one by one. So signature will give you the function signature. So let us see the function signature of the get method of the request library. So this is the signature. So the signature will actually can give you the complete detail of everything which is available, or all the information about different arguments of a given function. So let me keep it like sig equal to this. So what I can do is for param in sig dot parameters dot values, so I can get each parameter one by one and I can get its information. So let's check it out. So we get all the parameters one by one, and now I can get the kind of it. So here you can get the kind of it. So as we saw in the signature, URL, the first parameter, that can either be used as a positional argument or a keyword argument, both. Similarly, params can be used positional keyword, and quarks is actually a variable keyword argument, right? It can have a variable number of, you can provide a variable number of keyword arguments, all of them will go as a dictionary to quarks, right? So in this way you can get all the information that you can possibly find about the different arguments. But if you want to get all this information in some more detailed way, what you can do is inspect dot get full argspec, in which again you just pass the function object and you get it like this. So here you can see that what are the arguments, URL parameters, what are the variable arguments, what is the name of the argument which can be used as varargs, like which argument can accept variable number of arguments, none, there is no such argument. Which argument is present which can accept variable number of keyword arguments, yes there is, and it is called quarks, kwargs, like this. Do we have any defaults? Yes, we have a default. For params we have value none. And do we have any keyword only argument? No. And similarly some more information. Okay, so in this way we get all this data. Let's move on to the fifth application of the inspect module, which is unwrapping the functions. So what do we have to unwrap? So whenever you have a function which takes another function like the decorators, then sometimes you might want to have the actual function which is at the core, so that you can use it without the wrappers, right? So for that we do the unwrapping. So for example, here is a piece of code where we are using the LRU underscore cache decorator of the func tools module. So we have put it like this. So now this function will be getting cached, right? And this is the actual function. So if I just do func, I get it like this, right? Like LRU cache will also be used. So when you simply call func, some extra things will be happening. Not only this will also be happening, right? So now what if you want to just execute this much part? What will you do in that particular case? So for that, what you can do is you can use inspect.unwrap, and which you can just pass func like this. So now if we just see, we can see that it is now referring to the main func function, right, which takes a and b as an argument. So it will also work, right? So yeah, so in this way you can use the unwrap function. And now let me show you one more example so that I can explain one more important thing. So here is another example where I'm using two decorators. One is called timer, another one is called logger. So what are they doing is that timer will just take the begin time, end time, subtract it, and will tell you how much time it took to run your function. Logger will just print running function and then finish running function. And we have just put @timer @logger over our factorial function, right? So this is quite simple. So now if I just do factorial, I get there is a factorial function here, right? And if I just run it, I get running function factorial. This is the output. This is the actual function output. Finished running function, total time taken. So the first line, third line, and the fourth line are actually happening due to the wrappers timer and logger. So what if I want to just run the factorial function? How can I do that? So for that, again, I can use unwrap, but there is one more thing which is called wrapped. So there is a wrapped property which will return you the function in which you have removed a particular wrapping, right? So now if I do this, look at that. One level of decoration has been removed, right? So if I do wrapped again, so look at that. Now I am getting the actual value. So let's say my function has 3, 4, or 5 decorators. Then in that case, I have to use this wrapped chain, right, 5 times. But there is a very simple solution. When you are using inspect, you can simply do inspect.unwrap, in which you can pass the function and you can directly get the pure function, the original function. So in this way, you can directly unwrap to the base level of the function, the main function, and then you can execute it. So yeah, so this is how you can use unwrap. Okay, so now here is another super useful application of inspect module, which is getting the current state of generators. So you might know a bit about generators. If you do not know, I will put the link of the video which I have made about generators. And yeah, so let's see. So let me just make a function called values gen, in which I can just do something like for x in range, let's say 3, I will just do something like yield x. So this is now a generator, not a simple function. It is a generator function, which if you do values gen like this, it will not return you anything. It will not execute anything till now, right? So let me create a generator object like this. And now if I do gen, it is something like this. Then I do next of gen, and then I can get 0, 1, 2 and stop iteration, right? So now while you have this gen object, when it is written somewhere in your code and you want to know what is the current state of gen, there can be multiple states of gen. There can actually be 4 states of gen, which is it has just been created, it is actually running, like the function is actually running right now, or the function is actually in suspended state, which is it gave the result of a yield and now it has stopped, or finally it can be finished, right? So how do we get all those states? How do we know that what is the current state of my generator object? So for that, we can use inspect modules get generator state, in which I just pass the generator object. So I create a generator object, basically an iterator, and now let me run this. So right now the state is generator created. I just created a generator, and now let me use the next function on my generator to start executing it. So I just next gen and I get 0. So let's see what is the current state. It is suspended. Why is it suspended? Because the generator ran and after that it stopped after coming to the yield statement. Whenever the yield statement is obtained, it returns you some value and then halts, right? So yeah, so this is how it is working. And if I just move it again, still I will keep getting gen suspended until we get the stop iteration, and then now the state will be closed. It has closed, right? So yeah, so in this way you can use this pretty useful function to get the state of your generator. Another thing is that while you create a generator function, you might want to know what is the value of the different variables that are available there in your generator function. For example, x here. So you want to know what is the current value of x. You just put gen here. You do not know what is the value of x, right? So how do you get the value of x? So for that you can use inspect.get generator locals, in which you just pass the object. Okay, so let's see. Gen has been created, and Currently there is no local variable. Why? Because I have not run my generator yet. Now let me run next of gen and I get 0. So let's see what is the current value of the local variables. Look at that, x is currently 0, right? Now if I just run it again, I get x1, 2, right? So in this way you can get the current state of the variables in the local scope of your generator function like this. Now we move to the last application of the inspect module that we are going to explore in this particular video. So let's talk about getting the traceback frames. So we have a very useful function in inspect which is called trace, which will return you a list of frame records for the stack between the current frame and the frame in which an exception which is currently being handled was raised. So let me explain it to you in some simple words. So let's say I do 1/0. What I get is an error, and what you're getting here like this is called stack trace, right? You are tracing back what all happened which led to that particular exception, right? So now let me just try to do something like let me just make some functions here. Def divide, which takes a and b and it returns a divided by b. Now let me do something which just runs divide 1, 0, and finally let me do something. Okay, so now what will happen here is that we will get some stack trace which is of some levels. Okay, so here you can see that first of all we got to do something, then divide 10 was called, and then return AB. Here the actual error happened, right? So this is the trace that we are getting. So how do I get this particular trace in a programmatical way? Like, I do not want to raise an error, but I still want to get all this complete detail so that I can use it in some other ways. So what you can do is just put a try except, and then you can just do inspect dot trace. So let us just try to print it. Look at that, we get several frame objects in which we get the complete trace, like what all frames which we went through which led to this particular exception. Okay, so let me just show it to you in a pretty much better way. So for frame in inspect.trace, so we get each frame one by one. So let me just print several things here. So what can we do here is that we can do frame dot code context, right? So let us try to see what we get. Look at that. So first of all, we were at do something function, then it went to the divide 1/0, and then we went to the return AB. You can even get the line numbers on which that error happened. So frame dot line number, so you can get that 8th line, right? So second line is this one, so return AB is this line, and 5th line is this is the 8th line. So the lines through which we went through in order to reach to that particular error. So yeah, so in this way you can get the complete trace, and it is not that much required nowadays because you have some super cool IDEs already doing this stuff for you. For example, in PyCharm or VS Code, when you use the debuggers, then they can debug like from which line to which line did you go through your code which led to that particular error or anything that happened, right? So yeah, so this was all about the traceback frames, and this leads us to the end of this particular tutorial video, you can say. We just explored the inspect module, and yeah, most of the things that inspect module provides actually is already being provided to you in your IDEs as some features, right? So you might not need to use all these things as much, but still knowing these things can help you, and then you can later use them when you reach some situation where you might need these things, right? So no harm in knowing those things, right? So yeah, so this was all about inspect. I hope you found the topic interesting. I hope you got to learn something new and you might use some of these functions in your actual codes. So yeah, so this was all about it. If you're still having doubts, you can put them in the comment section below. That's it from this video. Thanks for watching.